Good morning, dear students. Very good morning. How are you all? Fine. So this is the second video of the week, and in this video we are going to talk about the Newlands law of octave. Okay, na? So here you can see that law of octave. Octave means eight elements. Okay, na? Eight elements means it is related to the eight elements, and it has given uh, to actually tell that after eighth element the elements will repeat its properties. We will see, and it will just behave like a musical note. Sa re ga ma pa dha ni sa, sa sa. Last first word first is sa, and last one is also sa. So that one is the resemble its law of octaves, eight elements. Okay, na? So that uh, is actually given by the Newlands. Okay, and what is Newlands law of octave? He said when elements are arranged in order of increasing atomic mass, you can see that here the basis of the classification and what is the basis of that law was again the increasing atomic mass. This is you have to remember in this chapter what was the basic. Okay, na? Basic thing was you should understand that what was the basis of that law. Okay, in some of the law you will remember that basis was atomic number, but here you have done about the Doberner's traits also, and in the Newlands law of octave also you will find that the basis is increasing order of atomic masses. Okay, na? The properties of the eighth elements are a repetition of the properties of the first element. Properties of the eighth elements are a repetition of the properties of the first element, just like a musical notes. So this is called the law of octave. Yes, you will get the example and you will understand that one. Noble gases or the inert gases were not discovered at that time. So here you can see I am actually giving you the idea about that one. When elements are arranged on the basis of increasing order of atomic mass. So if I will take hydrogen, okay, and if I will move in a row, okay, na, then we will find that here hydrogen would be there, then after helium was not known as that at that time because it has given a noble gas were not known. So I will take beryllium, boron, carbon, nitrogen, oxygen. Okay, na? Hide 1, 2, 3, 4, 5, 6. Okay, beryllium, boron, carbon, nitrogen, beryllium. What is the atomic number of beryllium? 4, 5, 6, 7, 8. Then after fluorine. Okay, na? Neon was not known at that time. Okay, then after magnesium, 12. Then after aluminium, then after silicon. Okay, then after phosphorus, then after sulfur. Okay, na? Again you will move to get some of the thing. So you can see that here one thing is actually lithium. You can also place lithium. Okay, and then here sodium. So what you are seeing, you are seeing that lithium and sodium, and when you will come in the third row, here you will find potassium. Okay, now so then after potassium 19 atomic number, then after calcium, and here you need not to write because this Newland's law of octave was working up to calcium only. So you can see here lithium is there, sodium is there, potassium is there. Then after beryllium is there, magnesium is there, calcium is there, and this one coming at the eighth position. Count from here: one number, two number, 3, 4, 5, 6, 7, 8. So lithium and sodium will show the similar properties. Count from here: boron, 1, 2, 3, 4, 5, 6, 7, 8. Okay, now you can see the eighth elements will repeat its properties. Okay, now will repeat its property means beryllium will repeat its properties with the I should write it clear. Here lithium was there, then after sodium, eighth element was there, beryllium, then after magnesium was there, boron, and eighth element was aluminium. So this lithium and sodium will show similar properties as it comes under the Newland's law of octave, and the very first element will repeat its properties with the eighth element. Beryllium will repeat its properties with the magnesium because it is eighth elements. Boron will repeat its properties with the aluminium, so it will show the similar properties. Okay, now you can see classification of elements based on Newland's law of octave. Here the explanation in theoretical theory it is given here. If we take lithium in the first element, then the eighth element will be sodium. Okay, na? Which will show similar chemical properties to the lithium. This verify the Newland's law of octave. Okay, and again if we will consider sodium as the first element, then potassium will repeat its properties. I have shown this one: lithium, sodium, and then after potassium. So if we will move in a row horizontally, we will see that beryllium would be there, boron would be there, carbon, nitrogen, oxygen, then eighth element would be this one. Then after again if we will move here from here, the sodium, magnesium, okay na, aluminium, then after eighth element would be this one. So all these will show the similar properties. Okay na. So here it is written, therefore these elements lithium, sodium and potassium are arranged vertically in same group. Here this one is written. Okay na. Okay, but there were some limitations of Newland's law of octaves were also there. As you know that Dauvergners and this Newlands were working to classify the elements, and Dauvergners actually arranged the elements in the group, and Newlands is actually placing the elements in the horizontally. Okay na. But never you can see that wherever Newlands was the second scientist, Dauvergne was the earlier, so Newlands was refused to accept what Dauvergners actually have done. Okay na. So this you can see, but later on Newlands had also some limitations, and this you can see the very first limitation was it was applicable up to calcium only, means only a lighter elements were there, only a lighter elements were there, and it was applicable with that one. Whenever the more denser element, or we can say heavier elements came na, the rule, the Newland's law of octaves was actually was not given the have not given the satisfactory explanation about that one. So this one was the drawback, this one was the limitations of Newland's law of octave. Then after Newlands assumed that there are only 56 elements existed in nature. He told the world that in the future only 56 elements would be there, no new elements will come. But later on, today's we are actually doing 118 elements. So and it is given, and no new element would be discovered in future. So he could not think about the heavier element if found further. Okay na? So this is the thing you should know, the limitations. Second slides we are doing. He placed even two elements having different properties together in same slot. This is one of the major drawback. Two different properties he placed into the same slot, and that is never acceptable to the world. So this is one of the great limitations. So you can see, for example, he placed CO and Ni together in one slot. Okay na? Even different elements were put together in the same column. Here CO and Ni both is having different property. So why he had actually taken the same slot and he placed here CO, little bit big I have to take. So here he took CO here and nickel in the same slot. Okay na. So that one was the confusion. Okay, iron resembles with cobalt and nickel. Iron, so iron resembles with cobalt and nickel, but he couldn't able to place this iron in between cobalt and nickel. He placed this iron at a very large distance. So this one was, once again, this one was the problem. And then after, you can see that noble gases were discovered later. Noble gases were discovered later, and he couldn't explain anything about the noble gases. So if noble gases will come, where in this Newland's law of octave, where the place of that noble gas would be there? That one was the question. And when the discovery of noble gases were there, then it made, actually, disturb, it disturbed that periodic table. Okay na? So here it is written that noble gases were discovered at a later, okay na, and the whole arrangement of the table were disturbed by their inclusion in the table. So this is the thing you should know. And we should know that Newland's law of octave was also not one of the success it has got. Okay na? So that one was the drawback of the Newland's law of octave, and we will actually work with the new periodic tables law, and that one will be the Mendeleev's periodic table. Okay na? We will do in the next class. Thank you.